Sometimes we want to know in math if there's a connection between two different variables, so if one variable has an impact on the other. A scatterplot is a great tool for just getting a good visual on whether two variables are related, and we can also use a scatterplot to do more complex calculations. So I wrote on this slide right here just a bunch of different scatterplots, and we're going to do a little bit of vocab related to what you see in the pictures here. So if you want to, the dots themselves don't have to be exactly in the same spot, so you don't have to be that precise with it, but I would sketch these out and try to make it look similar to my pictures here. I have each picture labeled with the two variables because I'm going to talk about the difference in where they get placed. So first, let me draw your attention to the note down in the bottom right here in purple. The independent variable, which is x, affects, or you want to see if it affects, the dependent variable y. So in my first example here, we want to see if the hours you study affect your grade. The one at the bottom has an impact on this one over here, or we're hoping that it will. Next one, you want to see if your distance from school affects how long it takes you to actually get to school, your commute time. Amount of money, you want to see if it affects how many late fees you get, and so on. Each of these problems right here, the variable on the bottom is the one that's kind of in place. The independent variable is there, and we're seeing, okay, how does that change my y, or my dependent variable? So for each of these problems, that's basically what's going on. Now, you'll notice that when you make a scatterplot, first of all, I guess I should probably mention this. When you plot points in general, and I'll erase this part in a little bit, we use the coordinate grid with all four quadrants here, and we put dots going in on x, comma, y. When we do scatterplots, we really only focus on this part of the graph right here, just that upper left L there. We kind of ignore the rest of it. So all we're looking at is that top left quadrant. The reason for that is when you're doing scatterplots, typically your variables are both positive. You're not going to study for a negative number of hours or have a negative grade. So scatterplots typically just deal with that first quadrant because it's real world data and you don't typically have negative answers. So if you look at that first picture there, notice that even though the points aren't in a perfect line, there is a pattern to them. They're kind of going up like that green line right there. They're pretty close together, like they're maybe not exactly in a line, but they're not far off either. We would call that a strong positive correlation. Strong because they're really packed together. It's like a pretty good fit there. Positive, think about slope. The points are going up as you go along. And correlation is kind of the word. They're related to each other. So they're a strong positive correlation. Sometimes you will also hear the word linear thrown in here. A strong positive linear correlation. That's just basically saying that it's positive, yeah, it's going up, and they kind of make a line. So that part, sometimes you use it, sometimes you don't, but it is technically a linear correlation too. On my second example here, it would appear that as your distance from school gets bigger, your commute time goes up, which kind of makes sense. But where the last one, the points are really packed together like this, and they're pretty close to that green line, you can see on this one, they are going up, but it's a lot more spread out. So there's a pattern, but it's not as strong of a pattern. We would call this a weak positive correlation. Yes, there's still a connection there, but it's not as nice of a fit as the first one. Kind of spread out, really packed together. On this next problem, this is the points are kind of going down like this. Think about slopes again. That is a negative correlation, and it's kind of spread out. So I will call that a weak negative correlation. And this one is almost a perfect correlation right here. They're almost entirely on that line. So that is a strong negative correlation. And again, with all four of these, I could add the word linear in there, and that's fine. It's not necessary, but it is true. It's kind of a linear fit. Two more problems down here at the bottom. We have number of pencils owned versus hours of TV watched. Now, it kind of makes sense. Like, if you look at this graph, it's just all over the place. Really can't tell what's going on here. They're just points everywhere. There's not really going to be a connection between the number of pencils you have and the hours of TV you watch. So you see the dots are all over the place. We would say here, this example is no correlation. So there's definitely nothing going on there. And the last one, I kind of erased this here. This is items produced versus profit. So apparently when a company makes a certain number of items, their profit goes up. But if they make too many, they're going to start losing money because they won't be able to sell them all. So there is a pattern to this graph. It kind of goes like this. It starts up and then it goes back down. But that's not linear like the other ones were. They all made a straight line. So what we would say, there is a correlation, but it's a non-linear or not linear correlation.